you're going to be changing on a material or the base color, which you can just use a color like this. You know, picking some overall color for thing, but really what it's expecting is an image if you have one. So if you have a texture of some sort, that would plug right into base color as an RGB image. And like I'll just do that kind of as a placeholder here. I'll just make a new um, color grid texture. I'll
Yeah,
just
Blender
call
can
this
generate some
color
sample
grid.
images for you, which is useful.
I like that. I bet there's a way you can like make your own and populate this list. I would love to do
That'd be
that.
cool.
But anyway, if you make like a little color grid, it's just a 1024 image and plug it in. Let me get out of full screen here. You know that that would export to glTF just fine,
Hmm.
and it would have the base color on it. Now, what it would have though is a default roughness. So how shiny this thing is uh, right now is controlled by a slider. So if you bring it all the way down, you're talking about something that looks really glossy, really reflective. Now, bear in mind, it's not going to reflect the whole world around it. It's not going to reflect avatars and other objects and
Yeah,
things.
we do set a default environment. So the thing that you are going to see in the reflection is the environment map, and we do set a default environment map from the scene that you've loaded, which we generate from the skybox. So if you have like a skybox that you configure in Spoke, like there's that skybox element, I mean you can configure the different parameters of that and create the skybox. Then when you have a shiny model like this, you're going to see the reflection of the skybox in there. What we don't do, like if for a lot of people, for example, use 360 images, just wrapped around a sphere in Spoke to create a different kind of skybox. That's not going to reflect in the environment map right now. We want to have that as an option
Right,
where you
like
can
this
actually
kind of
specify in the
thing.
environment map. Yeah, like you're not going to see that. You're only going to see like the sky that you actually set up in Spoke as the sky map, which or as the skybox.
Right.
Which works for some scenes but doesn't work for others, and so reflective surfaces may look kind of weird. Um,
But you can also use an image for roughness. So
mhm.
you can use a texture that defines what parts are shiny and which parts are not. Um, if you don't need any, I usually just turn roughness all the way up so that it's just
Flat, yeah.
shininess is not an issue at all. Similarly with metallic, metallic is another thing that is supported. Um, Making a surface metallic is and smooth like this, like really gives you that sort of chrome. Uh,
Yeah, you can find there's like the examples with all the spheres or whatever. That's like a good way to see the gradient between
oh yeah, like
fully metal and fully rough.
so you can play with that. But by default, these settings are just pure scalar values like 0 to 1.
Hmm.
But if you have an image, like I don't think this color grid's going to do much for me.
No.
But if I had a another image that had like black and white areas on it or grayscale
Yeah, and we
areas.
use this, for example, on the default robot avatars. Only certain parts of the robot are shiny, and some are more shiny than others. And so you'll if you look at the roughness map for those avatars, you'll see that there's like strips of it that are not that are darker or lighter, depending on how shiny they should be.
Yes. Now the weird thing about plugging in textures to this node is that um, it's kind of expecting that you have an image where different parameters are separated into the red, the green, and the blue channels of the image. And
Yes.
what's in this case we call it an ORM or an uh, occlusion roughness metallic. That's what that stands for. ORM.
Yeah, and the reason, those are all those maps. Those three maps are all single, like a single channel. Like it's not RGB. It's just gray or yeah, black and white. So we can put all three of those into a single texture to just to save space
So
basically.
like this is the robot avatar from Hubs,
Right.
and this is the ORM map. So in Blender, I can actually, instead of viewing it all as one big overlaid image, I can just look at the red. So you can see that's actually the occlusion map.
Hmm.
If I switch to G or green, it's going to show the roughness. This is the one where he's wearing a tie. And then the blue one is what parts are metallic and how metallic they are. So you can see like the tie is like a little bit metallic,
Right.
whereas these areas are very metallic, or Yeah, that's right. Very metallic, and the black areas are non-metallic.
Yeah, and
Um,
they're in that specific order: ORM, like occlusion, roughness, metallic,
yeah.
metalness.
Whereas like with the roughness, you can see there's kind of a tweed pattern on this suit, and it's a little like some areas are shinier and some are less. In the case of a roughness map, if you don't know this, it's kind of like opposite what you might think. Like rough, more rough means like not shiny. So um, the whiter it
Because like a
is,
shiny surface is polished, right? It's not rough.
right. So
It's
the shinier parts are black. In this case, like his belt buckle right here under the tie is darker to be more shiny, more glossy.
mhm.
So, but you can't just plug this straight in anywhere. You have to do a couple things. Number one, you have to change the color space on this node from red, green, blue, because we're not looking at all channels together like this. We change this to non-color. So it's going to use non-color data. This is probably the thing I forget to do the most when I
I
go
don't
to
even know about
export.
that. Yeah.
Yeah, you can switch it. And it's a here's a really good it's a hot tip. If you change to a different map, it resets this. So you have to like make sure if you do change it, that you switch it back. Actually, it has a memory. It's like it remembers this was non-color.
I think that's probably a property of the image itself.
Yeah, it's like
Potentially
doing it that way. Now,
image
what you
embedding.
need to do in order to split this out into the metallic and the roughness parts is add what's called a separate RGB node. That can be found under add converter
And I'm pretty sure.
separate
So like
RGB.
you can actually, if you wanted to, have these as separate maps, and you wouldn't have to do this.
Correct.
But it's definitely better if you can. And all the models we provide are going to be in this way, and this is a pretty standard technique. So um, uh, combining them together into one map is just better because it's you're only using a single channel anyway.
And
But
you're
you
saving
can separate
you're
them if you
saving
want.
download time a bit because it's
Hmm.
only one
Hmm.
image instead of three.
Yeah,
So,
download time and actually CPU memory as well, or sorry, GPU memory as well.
all
So
right.
it's definitely useful.
So we know
Um,
that the green is the roughness part, the R. So we plug the green of this separate RGB into the roughness. Let me go full screen on this. And then we plug the blue, which is metallic, into metallic there. Now the this is the weird one. The red,
mhm.
which is the as we just talked about
Occlusion.
the occlusion map, like what's known as ambient occlusion. And if you don't know what that is, that's just the way that you sort of add what's called like self shadowing. So like areas that are in cracks or like under a character's armpits or things like that that you want to look naturally darker than surrounding areas because it occludes or blocks ambient light. That comes out of the R here, the red channel. But I'm going to come back to that one because
Yeah.
making that needs a special node to export. There is no ambient um, input on this shader in Blender. So there's sort of a weird workaround to do that. The glTF documentation that we showed earlier explains exactly what that is and what it's looking for, but we'll get back to that. The last thing
And
that
this is kind of similar to like what we did for light maps too, right? So light maps
yep,
aren't supported in the default Blender BSDF node, so we created a separate node that you pipe things into that then at
this
export
guy.
time it looks at. And so yeah, exactly this thing. So you can pipe something into that, create a light map. There's a similar node, although you have to create it yourself for occlusion maps in the GLTF.
I'll show you the weird way I do it, and I'm sure maybe somebody out there will know a better way. But the last thing I'm going to add to this is the is another image node and load in a normal map. This is like the weirdest thing I'm making because it's a cube, but it has like
It's this cube with the
with a
robot with the
robot
robot.
thing on
It,
it. I might as well
it's
keep
fun.
going with this robot thing.
Yeah, at least all the maps line up. Yeah.
Yeah. So the normal map of this, and here's what a normal map looks like if you've never seen one. Uh, Usually looks like this. It is a weird purplish looking image that has some blues and some pinks, like magentas in it. And
Hmm.
this basically is telling uh, the renderer what areas are kind of like bumpy. And so uh, if you're familiar with like a bump map, which is usually just a black and white image, that can work for models. But a normal map actually has more information in it because it has four directions. So it can kind of
Yeah, I
tell
mean,
you
so
like,
effectively, what you're doing with a normal map is it's almost like every single pixel of the texture is a triangle. And then each of those triangles can be pointing in a different direction, like they have a different normal. And so the actual color value doesn't mean anything like visually, but the R, G, and B map to the X, Y, and Z of that vertex normal. So it's like it's telling it where to point the surface of that kind of imaginary triangle on that pixel.
So
And
like
so it lets you have
there's
like
the
really,
red
really
channel
fine
by
detail.
itself, right? There's
Yeah.
just the red, and then if you switch to the green, you'll see it's almost like the light changes direction. Now you're going to see it like coming from the top because green is treated like that, and blue comes from where does the blue come from? I forget. But
Well, I mean, it's the X, Y, and Z. It's the X, Y, and Z values of the vertex normal. So they kind of happen, or they look. You will see kind of like it look like lighting, just because that's going to be the different surfaces pointing kind of in the same direction. But it's actually just literally a vector encoded into the X, Y, and Z values.
this is kind of
Um,
like the most magic of all maps. Like and it
it would be
adds
pretty hard to generate these by hand. So I mean, typically, what you do is you take some sort of higher resolution mesh and then generate the normal map from that. Is that
yeah.
right?
Yeah, that's usually how it's done, unless you're using some other like third-party program like a Substance Painter or
To
something.
procedurally generate the surface. But like you wouldn't really be able to paint one of these by hand in Photoshop. That would not it'd be it'd be pretty hard.
Challenge accepted, Dom. No, I
Yeah,
would not want to do that. That would be terrible.
yeah.
But if the way that's set up is you drop the normal map into an image node like this. Again, you're using non-color data, just like the ORM map that we just did. And then you also need to add a normal map node. Again, that can be found under add. Where the heck is it? Is it a shader thing? See, this is why I make favorites because then I don't have to remember where they all go. So
There's a way to search them
yeah, you
as
can just
well,
search
right?
at the top here and type
Yeah,
normal, and then there it is, normal map. Not the one called normal, the one called normal map. You'll know because if you pick the wrong one, the
and
normal one has like
plug it.
balls on it, and you don't.
Uh,
That's not the one you want. But this regular normal map, and then you just chain that through. You go color to color, and then this normal to normal over here, and now the normal map is actually affecting this object. It's weird because of my UV layout, but there's this tie running along the side there, and his lapels, and
and you'll see like if you change the shininess values, and or actually, well, then never mind. You're applying a map now, so
well, I can add a
it's gonna apply
light,
that way.
and you'll see it.
Yeah,
So
yeah.
if I add a light to my scene, like a little point light here, and I switch to use scene lights and the scene world, right now it looks very dark because the light is hiding. But if I move it out here, oh, look at that. Now you're seeing not only the bumpiness of some of those surfaces, some of them are shinier than others. So there's the belt
Right.
buckle right there between. Uh, if I move this guy around, you'll actually see it's shinier on that belt buckle because of
Yeah,
the
and most of like
roughness.
again, we've I kind of say this every time we're working on stuff in Blender, but most of this stuff is kind of not really hub specific in any way. Well, definitely not hub specific, and mostly not even GLTF specific. Kind of only some of the things are specific to how the GLTF exporter works, but most of the stuff is this is just standard stuff with how PBR materials work, how these physically based materials work.
Yeah.
And so this knowledge you can kind of apply across
Yeah, if you're
any
using
engine,
Cinema
any.
4D or something, like
Mhm.
the principles are all the same, and Maya and all that stuff. So, um, so that's kind of the basics. Now, I didn't do the R here, the occlusion map, because this is the weird one. Uh, it's expecting, and the GLTF group that decided on how to make this work uh, chose this because again there was no input for
Mhm.
the ambient occlusion. I kind of wish they had done it a different way, but it's not the worst thing in the world. And in fact, once you make one of these, you don't have to do it again. In fact, I have it in a quick. I made one called GLTF settings. It's in a little quick menu here. Um, but this is basically a group node. Blender has the concept of being able to group things. So, like for example, you could grab all this stuff and group it. I think it's Control G. And now I'm looking at that in. See how it's
As
like
it kind of as if it was one big node.
Yeah, and then when you back out of it, it's like, oh look, I everything's all jammed into one node now.
Yep.
So you can do that to save space and also to sort of consolidate things and make it easier to make like templates of stuff.
Yeah,
And
and
that
they happen to have made this thing using a group node. I think there are reasons they didn't do it the way we did the light map thing, but I'm not sure. And if those reasons are no longer valid, I want to see if I can, do a pull request and have it be just like the light map node that we have, because I think that's quite a bit more convenient
it
than just
might as
having
well
it in
be
a
a
menu
part
like
of the
that.
importer exporter, right? And then they could just
That's
have
what I mean. Exactly, exactly. So I want to see. I want to look into the history of why they got rid of the custom node type, because I think they did have a custom node type at some point and they got rid of it.
hmm,
Though I think it was they had a custom node type for the entire BSDF thing, and they decided not to do that, and so that they can use the regular BSDF node. And then I think as part of that, they ended up getting rid of this occlusion thing. So
I think
there
my
it might just
guess
be
is
like
that their
historical reasons and
reasoning
stuff.
was like, well, look at that what that looks like when you close it up.
Oh well.
The I think the reasoning is probably because for people's art pipelines, they didn't want people to have to make like a whole separate
Exactly.
material.
Exactly. So what's nice about the kind of using this principle of BSDF node is that for every like all your regular Blender files just work, and then the kind of little bits that have to be GLTF specific, you can add those, and they don't really affect anything else, which is pretty nice.
So here's how I make it. It's kind of a weird workaround because you can't make a group node without stuff in it first. And so what I usually do is I start with one of these. I tend to use the one called Gamma because it has the very few parameters on it, like this Gamma node. And then I just select it and I immediately group it with Control G. Now I'm inside a group node, that's why it's green, and you can see the graph below it in the background, which is kind of cool. Um, I don't even need this anymore. So once I made this group, I can just delete that guy. And then what I need to do is change the inputs here to be something that the glTF format will recognize. So this is like a weird thing. I know this is kind of odd, but basically what you're going to do is make sure that your settings are open on the side. You can hit N for N as in Nancy, like N over here, and this will open this up. And you can go to node and see the inputs and the outputs listed over here. And this is where you actually edit them. So we don't actually need any outputs. You can select this and hit the X and clear it. I don't need the color one. I'm just going to keep this gamma one and rename it. And you have to call it this occlusion because the glTF exporter is actually going to look for that.
Yeah, and this is in that documentation page we
Mm-hmm.
were covering, and like you said, once you make this, it's probably nice to just add this to your favorites, so you don't have to ever make it again, or add it to your default blend file,
Yep.
so that you can keep it in there.
So this is the
Um,
only thing you need. It doesn't have to be hooked up to the output because there is no output. It's just a dead
yeah,
end
this is
kind of
just a
node.
thing that the GLTF exporter knows to look for, and so if it sees this node named GLTF settings, so you have to name it specifically. If it sees
That's
this
what I'm going to
node,
do next. So I'm going to go
yeah,
up, back out this little arrow up here in the corner in case you didn't know. Now it's just called node group and it says node group in here. Again, in the settings on the side here, go to the item tab and then it's actually the name doesn't matter. It's really the label. I don't know why.
yeah, and this can
Or
be like
sorry,
pretty confusing.
it's properties.
And this is like pretty, yeah, this is pretty confusing. And so when I was doing the light map node, the first version of it I did in the same way using this group node or whatever. And then when you copy this and you paste another one, it might call it like, light map settings .01, and then it's not going to find it. And so like this is like pretty error prone, and so like I said, I want to see if I can
Because look,
help
I
improve
just
this.
named this one glTF settings the way it's expecting, and then it renamed my other one .002, and
Right, exactly.
that's not
And
good.
so if you end up copying between materials, you're gonna have a problem. But uh, yeah, this is the way it is right now. It's not that big of a deal, but it's
But
just kind
once
of a
you
little.
make this,
Yep.
you can add it to your favorites, and you know then you're good to go. Now it has this occlusion input, and it's set to one. You can ignore that value because you're just going to plug the red channel into it, and you're
Hmm.
done, and that's it.
Right.
When I go to X, it doesn't change the look of it up here at
Yeah, I mean
all.
you can plug that into the occlusion map on the BSDF as well, just so that you can see it in Blender. Like plug that R output into it. I think that's
But
okay.
there is no occlusion over here. but I know what you're
Oh,
saying.
there is no occlusion.
Yeah, there's
That's right.
no.
You can add it as like a multiply node or
You
something
could
like
like
that. So you,
overlay it or yeah,
right.
multiply it with that. So,
Yeah,
but this is the bare bones like PBR shader graph for GLTF. I mean that's
yeah.
like as basic as it gets.
And obviously, like all these things are optional. You don't need to have like a normal map and a roughness map, and you don't have to have all those things. They're all optional. But like this would be a full PBR material, is all those things.
So you got the base color, you got the ORM here, and you got the normal. Um, and so that makes it so that and this one being actually three textures in the middle um, means that all in one we're going to have three, four, five different textures that make up the look of our PBR material.
Hmm.
And again, like I said, there are things like clear coat and all that stuff. I actually haven't
And there are also
tried
like
those
other
yet, but
modifiers too you can apply in between these things. Like you can add multiplier like or factors or whatever. This is covered in that doc page. There's even a sample graph they show with like all the modifiers applied. Um,
yep.
but yeah, those are all
And those you
optional.
can do with multiply. It's really just a matter of
Mhm.
adding like a mix RGB node and changing it to multiply, and now you've got what they call the factors. It will multiply whatever the color is by this
Right. So you
color.
can tint your image, for example,
Yeah.
and that actually gets applied at runtime too. So like
So
if you
I
are
wanted this more
creating a
purple, and I like turned it up, and
if you're creating like a custom hubs client or something like that and you want to modify this at runtime, that factor can actually be modified at runtime without having to like generate a new image. um,
but yeah, I again encourage you to read the docs and the Blender docs and understand those a little better, and also the GLTF docs will explain what there's base color factor and emissive factor. Oh, I forgot emissive.
oh yeah,
Speaking of
we
which,
should talk about that one
um,
because that one
yeah,
specifically someone was
this
asking
one
about
is
the other day too.
a little funky. Same idea. You can either just make the whole thing like an emissive color, or you can use a texture. If you're just doing a color, you're going to add a node called emissive. Where is it? It's under. I forget where it is, but I have it in my favorites. I'm terrible. Let's see. Emission. It's an emission node, and the emission node can have a color and a strength, but you can also plug a texture into it. So, for example, if I wanted this same texture, the color, the base color, to
Yeah,
be
I mean
the emission.
the bot one has
Look
we
at that!
have
I
an
just
emissive
drew it
map
with
for
a
the bot too.
line instead of connecting it. That was so stupid. Wait, how do I get rid of that? Where's the eraser? Oh, there it is. Eraser. Get out of here. That was a mistake. Yeah, you go like you could like plug the same color in, and then output it. Now, the way you make it work is you can think of these two as equal. There's the emission part and the BSDF part. You need to mix these two shaders together. And there's a node called mix shader, and you plug them in, one, two, and then have that go out.
Yeah,
And
no,
you
I'm not.
leave
I'm
it
not
at.
really sure why they can't just use the like because the BSDF shader does have emissive. I think so. I'm not sure why you can't just plug directly into that, but I'm
It's
pretty
because it
sure.
came later. This
Yeah,
didn't get made until like Blender 2.8
got it. So that it
7
just
or something
predates it.
like some yeah.
That makes sense.
But doing this now, this you can see it's like all lit up with the same color as this. The cool thing is you can actually turn that higher, and that'll get exported. So if you
Yeah,
really
and
want it
and
to look blown out,
we use this on the robot avatars for their eyes and the chest screen is glowing, and so like even if they're in a dark room without lighting, the eyes and the chest will glow because of the emissive map.
so here's the actual, and you set that one to RGB, like a standard RGB color. Um, Now it's using emissive, and the emissive texture, like you said, is really just the eyes. You can see them here lit up
Hmm.
on the robot. So somewhere along here, there's going to be a part that looks lit up, if I'm not mistaken. You know what it is? There's no part of it that's on the UV map right now. Look,
Mm.
they're up in the corners there.
Ah, yeah. Well, you can just
But I
move
could
the.
move this over just so like one of the eyes shows up, and then now when I go back, you'll see it somewhere. Where's the lit up eyeball? Oh, there it is. Looks terrible.
Yeah.
Thanks. I hate it.
And
Okay.
you can change the factor on there as well, so that it'll
Yep. You
um,
could add a multiply here afterward, like
yep.
a mix RGB, and set it to multiply. Where are you? Multiply. Um, oh, sorry, I have to do that before the emission because this is a shader output, not a color
Right.
output. I'm using the Node Wrangler add-on for Blender that comes with Blender, which makes me be able to do stuff like hold Alt and just pull this out, and it'll like reconnect
Oh,
automatically.
that's cool.
It's really cool. It has a bunch of other features like being able to like auto mix, like this mix I could have done. It's really cool. Like you hold Alt and then you like uh, right click and then do that and then it that didn't do what I wanted. I don't know. There's like I haven't learned all the little hotkeys, but there's like all these cool things you could do that'll like auto just like make nodes for you and stuff. But so yeah, so now there's a factor here between the image and the emission, and I
Right. So
could
you can
like
multiply it by a color.
make the eyeballs like glow red or something if I
Yep.
wanted to. And
And yeah, so I mean, I think this basically covers most of the common issues we get asked about materials, except one of the big ones that we get asked about all the time, transparency.